This is part 82 of C# tutorial. In this video, we'll discuss the generic queue collection class. Queue is a generic first in first out collection class that's present in system.collections.generic namespace. That is the order in which we add items to the queue. The same order will be used to retrieve items from the queue. This queue collection class is analogous to a queue at the ATM machine to withdraw money. The order in which people queue up will be the order in which they will be able to get out of the queue and withdraw money from the ATM. This queue collection class also operates in a similar fashion. The first item to be added to the queue will be the first item to be removed from the queue. Let's understand this queue collection class with an example. We'll be using this customer class in this demo, and notice that this is straightforward with 3 auto-implemented properties. Within our main method, we are creating 5 instances of this customer class, customer 1 through customer 5. First of all, let's go ahead and create an instance of this queue class. So queue, and what type of queue do we want to create? We want to create a queue of customers. The type here is going to be customer, and let's give it a meaningful name. Let's call it queue customers. And just like how we can specify an initial capacity of a list and a dictionary, we can also specify the initial capacity of the queue using this overloaded version of the constructor. But let's use the default constructor that doesn't expect any parameters. And then to add items to a list, we use add method. Similarly, to add items to a dictionary, we use add method. But then to add items to a queue, we use enqueue method. So let's go ahead and use that enqueue method and add an item to this queue. So let's add customer 1 object. At the moment, there are no elements within this queue. So this customer 1 object will be the first item within the queue. Let's now add customer 2 object. So where will this customer 2 object be added? This customer 2 object will be added at the end of the queue, meaning after customer 1 object. So what is this enqueue method going to do? Look at the IntelliSense. It adds an object to the end of the queue. So these objects will be queued one after another. So similarly, let's add customer 3, customer 4, and customer 5. Alright, so these customer objects will be enqueued in that order, one after another, because every time you invoke an enqueue method and then pass it an object, that object will be added at the end of the queue. Now, to retrieve an item from a list, we use its index, the item's index within that list. And similarly, to retrieve an item from a dictionary, we use the item's key. But then to retrieve an item from a queue, we use dequeue method. So queue customers dot dequeue. And look at the IntelliSense. What is it returning back? It's returning a customer object back, because this queue is a collection of type customer objects. And then look at what it is doing. It is going to remove and return the object at the beginning of the queue. Okay, so if you retrieve an item from a dictionary by its key, it returns that item, but then the item will still be there in the dictionary. Similarly, if you retrieve an item from the list using its index, it returns the item at that index position, but then the item is still going to be present within the list. But then if you use this dequeue method, the item that is present at the beginning of the queue will be removed from the queue and then returned. Okay, so let's store the item in a variable of type customer, and maybe let's call it C1. And let's say we want to print the customer's ID and name. So C1.id, and we want to print their name as well. So C1.name. So this dequeue method is going to remove and return the item. So after the first customer object is dequeued, let's find out the total count of items that are available still in the queue. And to find the total number of elements that are available, that are present in a queue, we can use the count property, just like how we have used it with the list and dictionary collection classes. So let's say console.writeLine total items in the queue. So queue dictionary, queue customers dot count, And again, we can either use this count property or use this link extension method. We have seen how to use this link extension method with list and dictionary, so we would use that in the same fashion with the queue as well. So let's use the count property. Alright, so let's go ahead and run this now. Okay, so look at that. The output that we get, the customer ID is 101 and name is Mark. And if you remember, this customer 1 object has got an ID of 101 and name is Mark. So when we use this dequeue method, since customer 1 object is the first item that is present at the beginning of the queue, that's what will be dequeued. Okay, now let's go ahead and dequeue one after another. Let's try and dequeue all these customers from the queue. And to speed things up, I have already typed some code, so let me copy and paste that right here. And this code is very much similar to what we have here. So basically we are retrieving customer 2, customer 3, customer 4 and customer 5, all the customers. Okay, so let's go ahead and run this. And look at this, as we dequeue customers, the count also keeps reducing. Okay, alright, so what is the purpose of dequeue method? It's going to remove and return an item that is present at the beginning of the queue, and to add elements to the queue we use enqueue method. Okay, now is it possible to loop through each item that is present within the queue? Absolutely, we can use for each loop, just like how we can use the for each loop with other collection classes like list and dictionary. In a similar fashion, we can also use it with our queue collection class. So for each customer, let's call it maybe C, in customers, queue customers. So let's go ahead and print their ID and name, and then the total items that are left within the queue. So here the reference variable is C, so let's go ahead and change that as C. Alright, and let's get rid of this piece of code. So basically at the moment within the queue we have these 5 elements, and then we are using a for each loop to iterate through the items within the queue. Okay, so let's go ahead and run that, and look at that. It iterates through all the customers within the queue, and then look at that, the total count is still 5 as it is iterating through, because the for each loop will not remove the items from the queue. It simply iterates through them, and then in this case we are printing their ID and name and then the total items within the queue. Alright, now we know that the dequeue method is going to remove and return the item that is present at the beginning of the queue. Is it possible to return the item that is present at the beginning of the queue without removing it? Absolutely, and for that purpose we have a method called peek. So let's go ahead and use that method. Look at that, when I say queue customers dot peek, look at what the IntelliSense says. This method returns the object at the beginning of the queue without removing it. So let's get this customer object out that is present at the beginning of the queue, and maybe let's store in this variable C, and then let's go ahead and print their ID and name. Okay, so all we are doing here is using the peek method to return the item that is present at the beginning of the queue. We are printing their ID and name, and then we are also printing the total count. So let's go ahead and run this. Okay, look at that, we get the first item that is present at the queue, and look at the total count, it is still 5. So peek method is going to return the item that is present at the beginning of the queue without removing it. Okay, so that's the basic difference. Dequeue method is going to remove and return it, whereas peek method is going to return that without removing. Okay, now what's going to happen if I copy this piece of code, paste it here, and look at that, we are calling peek method again. Okay, and let's call this reference variable C2. Okay, now so here it's going to return the object that is present at the beginning of the queue, which is customer 1. If I invoke a peek method again, will it return customer 1 object or customer 2 object? it will return still customer1 object because that is present at the beginning of the queue and it's not removed. So no matter how many times you call this peek method, you are still going to get the same object, which is customer1, because that is still present at the beginning of the queue. Alright, now how to check if a specific item exists in the queue? You can use contains method, just like how we have used it with other collection classes like list and dictionary. We use it in a similar fashion. So for example, queue customers dot contains. So this method is going to return true or false. So pass the object that you want to check whether if that exists within the queue. Let's say I want to check for the existence of customer1 object. So if queue customers dot contains that customer object, let's go ahead and print a message saying customer1 exists. Else, let's say we want to print a message saying customer1 doesn't exist. So does not exist. Alright, so we do have customer1 object. So what's going to happen? It's going to print customer1 exists message. Let's run this and look at that. If it doesn't exist, it comes into else part and it's going to print that message. Alright, so to add items to the end of the queue, use enqueue method. To remove an item that's present at the beginning of the queue, use dequeue method. A for each loop iterates through the items in the queue but will not remove them. To check if an item exists, use contains method. What is the difference between dequeue and peek methods? Dequeue method removes and returns the item at the beginning of the queue, whereas peek returns the item at the beginning of the queue without removing it. That's it for today. Thank you for listening. Have a great day.